All right, well, let's go ahead and let me introduce our panel here. We have Eric Pugh, Yannick Seeley, and Steve Rowe, all experts in Lucene and solar technologies here. So they're going to be basically the judges of who stumped this chump up here. All right, so, well, let me back up. Let me take a question from the audience first. This guy right here came up.
Hello, and the question is the problem. You have many documents with many fields. Each field may contain, for example, 3 terms. And what is most efficient way to check if the user has mentioned all the terms that exist in this field in his request? So by the count, they may go in different order, yes, but they should be all present, all the fields present.
Okay, so first off, hi everybody. Okay, so wow, all right, real-time slide creation, folks. You saw it here first. So the crux of your question here is that when a user gives you a multi-word query, it's not enough to say, I want to find documents that contain all of those words. You want to find documents where they don't contain any other words. Is that right? Am I understanding correctly?
No, a bit different story. We want to boost it, set it higher.
Okay, so I'll give you, so for a concrete example, for example, a book title maybe might be, well, now I'm blanking on a good book title.
This might be a person name.
Person name. Okay, right. So good. So my name is Chris Rumpelstiltskin Hostetter. And if someone searches for Rumpelstiltskin, that might be a match on my name, but it's not a total match. If someone else's name is just Rumpelstiltskin, that's their entire full name, they should match higher than me. Is that your goal? Yes. Okay, but am I still a match because a part of my name is a match? Okay, so if that's your goal, and then obviously a more complicated example is someone searching for Chris Hostetter. I'm also a match. Rumpelstiltskin is not a match, but someone whose name is just Chris Hostetter with no middle name, they should match higher than me, right? Okay, so what you're describing there, the default scoring algorithm in Lucene and in Solar should already give you that ordering based on length normalization, right? So if you have length normalization turned on for your field, then in theory, the longer the value, the more the score is penalized, unless it matches more terms, in which case the score increases and everything's all happy and fun. But in practice, what the problem you ran into is that you can have issues with norm encoding and boosting and things like that. The general rule I would say is when this kind of a problem is important to you, don't use document or field boosting for starters, because document and field boosting just throws off the equation. If you have other cases where you need document boosting or field boosting, I would recommend encoding those as a numeric field and using function queries instead, because the boosts are going to throw off that length norm. You know, the way I look at it is the norm is the only place you can get that length factor. So take your boost out of the equation because there are other ways you can do the boost, but the length has to go there. The second problem you have is that norm gets encoded into a very small value. For those of you who aren't familiar, who here knows what I mean by norm and the fact that it's encoded in a small value? Who has no idea what I'm talking about would like me to explain it? Okay, a couple people. No, that's good. I want to know because I want to, I don't want to like gloss over something and have everybody be like, what the fuck is he talking about? So basically what happens is this numeric value, which in theory should be an integer, for historical reasons of space and time and that everybody only had 64 kilobyte computers, that number was compressed down. Sorry, not an int, a float. That number was compressed down and basically only stored in a byte, 5 bits for the 5 bits for the exponent and 3 bits for the mantissa, or vice versa. I don't remember which. But the point being that 2 values, a field that had 3 terms and a field that had 4 terms, their length norm might wind up being the same, right? And that's where you can kind of get screwed on that. So customizing your similarity a little bit to more accentuate the fact that you know your fields are going to be very low values anyway, so that that length norm is actually discrete for each of those individual values. That can help eliminate that tiebreaker problem that tends to come up. I think it's right around 3 and 4 terms where it really burns you. There's probably another one at like 6 and 7 or something. But I would customize your similarity. I would make sure you're using norms. I would eliminate field and doc boosts, or at least field and doc boosts there. You could use field boosts somewhere else, but personally I would eliminate them altogether. And then I think the scoring algorithm should do what you want. If I've misunderstood your problem and the scoring algorithm won't do what you want already, then I would start looking at custom functions and custom fields where I index the length of the name, you know, as a number. And then I say, I know my query is this many words. I want to find documents where the field length is that many words, or I want to boost where the field length minus that number is higher, you know, and you can put function queries in like that. I'll have more examples of that tomorrow morning. So would the panel like to say how I'm an idiot?
Could IDF values also screw up your ranking, the default ranking?
Yes, correct. So you want to customize your similarity. You may want to, I don't know if you may want to repeat that.
You may want to customize your similarity, was what Haas said, to eliminate the IDF factors too, because more rare terms, rare names are going to score higher and also screw up your rankings. Yeah.
You didn't mention chord factor in scoring, which could be it could be the case that even if you match all terms of a query, that a field could be longer than that. You might want to put more emphasis on the chord factor in order to get a better match.
Conversely, in the specific case, actually eliminating the chord factor might help for him, because he cares more about an even gradient of scores based on the length, and not so much the exponential factor that chord normally applies, right? Like you almost want a linear chord factor, whereas the default chord factor is exponential, I think, right? Something like that. The point is, similarity is your friend, and you really need to look at your similarity and customizing. Yeah. One second. It's cool. I'll repeat it. What he said was he was thinking actually about customizing the way the phrase query works, so that he's actually looking directly at the posting list as part of the query. I mean, I think that works. It's just that's probably like that'd be like the 5th thing I tried.
Yeah, it's probably will hit the size of the index and a bit slower. Probably I can first try. Just came into mind that slope factor. Set a big slope factor and see will it work.
Yeah, well, especially if you're doing these as phrase queries, then especially like that slop factor and having that large slop factor, and the closer the terms are, the better. And that's where people have done also tricks where they insert beginning tokens and ending tokens, and then they do a slop query, a phrase query that includes both of them and their words. And so the wider the field, you know, there's definitely stuff you can do like that. It's just you want to try iterative tricks, and that would be, like I say, 3rd or 4th on my list. So, okay, I think we've covered that question, unless, yeah, Eric doesn't like to talk, so.
All right, awesome. All right, next up I'll go to your query. Is this your question here? I'll let him explain.
Oh, fuck.
Hi.
I'm screwed now.
Nice to meet you too. You're a kind man. Yeah, really.
Mikhail doesn't like me very
Where
much.
are you?
I want to be able to read it.
Okay.
Go ahead, you can explain it though.
I have a really odd query which has a lot of words. Like, I need to put all of them into disjunction or into dismax parser. To have a huge disjunction which I want to constrain by mean should match. I have only one field, right? And I also need score. So many field, dismax, many words, single field, dismax, mean should match, score.
Okay.
5 components for success. Okay, this query runs several seconds.
Right.
And because of mean should match is really high,
Right.
it
Yeah.
returns only 3 dots. So 6 seconds really reasonable to me, because the core disjunction is really loosely selective query. Okay.
Mm-hmm.
Then to speed it up, I want to supply highly selective filter.
Right.
So I pick up 2 primary keys from these documents and put them as a filter query.
Right. The key being here that you're not actually trying to find everybody who matches this. You want to know what is the score of this query against these 2 documents right here. Right.
Or I want to know whether they in this search result. Right. So I want to check whether these 2 guys
Or in
the result
right.
of this.
But if so, what are their scores? You actually want to know their scores if they are.
Absolutely
Yeah.
need scores.
Right. Okay. And your question was how long will this query take?
Yeah. How long can
Less than the heat death of the universe, and more than 6 seconds. I mean, there was no precision requirement on the question, right? You just asked me for yeah.
To calculate scores for 2 documents,
Right.
or check whether they're or not, I need to score only 2 documents.
Right. Okay. So the problem. So the first part of the answer to your question is it'll probably take at least the same amount of time, right? And I'm assuming you already knew that because nobody writes this question without trying it first. So I'm guessing that you'll probably observe it take roughly the same amount of time or a little longer. And the reason why is because this filter is still being computed kind of independently and then applied to the results of that query, right? Wait, no, hold on. Hold on. It's all coming back to me now. The last 3 years of development. Yes, that's right. Wait a minute. Yeah, that's a good question. Which version of Lucene? Which version of Solar, I mean?
Okay, I have 2 questions.
Oh, now you have 2 questions.
Okay.
Okay. First question,
Okay,
what are you talking
to be
about?
honest, it's the same in both versions.
Really?
Really, the behavior hasn't changed.
Okay, then we might have a candidate for somewhere around second place here because I'm not actually sure why it would be that slow in 4. I'm trying to think. Well, all right. Let me start by just double checking. Am I right that when you tried this, it's still about 6 seconds or more, right?
It's slightly less.
Slightly less.
Less.
Okay.
But not significantly. It's seconds. Still
Right.
seconds.
And these are actually unique keys. Only one document matches each of these.
It's unique keys from 2 of these 3 documents, and nothing really changes if I put any other
Right.
primary key
Okay. All right.
as a filter.
Well, while I stall for time and try to think about this, I'm going to explain this question to people who may not have understood it, because that is the secret to how Stump the Chump stalls for time. Basically, the issue here is that this top query here, it is very loose matching query. For people not familiar with dismax and edismax, this parameter is basically saying I really only need to match half of the terms. And he's got a query where he's got like 75 terms. So this query is going to be matching a very large, presumably the base query is matching a very large number of things.
Yeah.
Right.
Base query matches millions.
Right. Well, I mean, you said if when you change it to 1, it matches
Right.
millions, and yeah, definitely. So the question is then, if he's filtering by these guys, why is it still slow or almost as slow? And in 3, the answer would be because this query, this is what I was starting to mention earlier before my brain woke up. In Solar 3, this query would have been evaluated independently, computed a bit set, and then that bit set would have been intersected with the one up here. As of 4, Solar 4, as of 4, this is still true because it's trying to cache it independently. If you say that the filter query doesn't need to be cached, if the filter query doesn't need to be cached, then it can be evaluated in parallel with the main query, and it will skip and bypass all but these 2 documents. You almost got me there, you little. You're supposed to give me these after I've warmed up a little bit, man. You're like dumping me straight into the deep end here. Right. So the reason this is still kind of slow is because for a lot of the things Solar optimizes for in terms of filtering and faceting and whatnot, it still assumes by default that these filter queries should be reused. And so it doesn't try to evaluate this filter query at the same time that it's evaluating the main query, because if it did that, this filter query would be bogus, right? I mean, in this case, you can see this filter query obviously only matches 2 things. But if this filter query is more generic, right, if it was like a category restriction, if it was evaluated at the same time as the main query might be ruling things out that this guy needs in the cache in case you use this guy later. So as long as you don't, how do I want to put this? As long as you don't tell Solar that you're only going to use this once, and you tell it you're only going to use this once with the cache property, by default it assumes you want to cache it. So by default it assumes it needs to know everything. So when it evaluates that guy, it needs everything. Am I wrong? No? All right, well then I'm going to turn it over to the panel to tell me how I'm wrong.
You're absolutely wrong. Bad guess.
So, hello. Okay. So your answer was put cache equals false because why?
Because if it's not being cached, it should be evaluated at the same time.
And why is that important?
Because then it can help rule things out of me. Is that not true?
It depends which version of Solar.
That's why he said 4.
It's very different. It's very different for reasons that might not be obvious. Let me see. In Solar, in early Solar 4 in trunk, and in Solar 3, we always skipped on the filter that was produced. So we calculate all the filters. We get this bit set or doc int set or whatever the filter, right? And then at query time, we use the filter. We make a filtered query for Lucene, and so leapfrogging happens, right? The filter is consulted about what's the first document it matches, and then the query is consulted about what document it matches after that ID, and they leapfrog each other until they land on the same document. And so in earlier versions of Solar, this should have been faster. At some point, there was a change made in Lucene to make some things faster in the general case. I think that's probably what's happening here, about pushing filters down towards the leaves, if it's random access. And in that case, pushing down, if this does get pushed down towards the leaves on this big disjunction, I don't know if that's what's happening, but that could be one explanation why it's not too much faster. The other reason that why it could not be too much faster, even if skipping is still employed, is just unlucky IDs, where they are in the index, because it's still half of the time it's asking the query what the next document it matches is, right? And so it's based on those 2 IDs, you're going to have a huge amount of variance.
So could you do like a star colon star for the query and then do the weighting of the filter caches? No, don't cache them, but of the filter caches.
So just to make sure I'm really clear here, Yannick. So in three, this still would have always been slow because this guy would have been done completely independently. That's what I was referring to, right?
No.
When was the last time this was done completely independent? I thought even in 3.6 it was.
It's calculated independently, but that's fast.
But it was still being asked in the leapfrog fashion up here?
Yeah.
Oh, okay, see, that's...
It's even before.
Right.
You got to go back to Solar 1.2
full,
or 1.3.
full mea culpa. I actually thought this didn't get leapfrogged even in 3. So that's way back. All right.
Yeah.
All right. So that's, yeah. You're already on the podium, basically. Yeah, but I see what you're saying. So the key here being that optimizations in Lucene that assume filters are a little more expensive and should be delegated lower are going to push those down sort of in the logic tree and assume that the query should be consulted first.
But of course, that should only happen with highly selective filters, I believe, that are bit sets. With a big index that only matches 2 documents, this filter should be just like a set of 2 integers. And so that logic should not be getting invoked. And so we should be going back to skipping again, in which case maybe we just got really unlucky.
Yeah. Well, oh, right. And that was the other thing I was going to clarify. So for people who missed it, Yannick's point about where the IDs live and how that affects things, again, we're speculating at this point about this particular example. It didn't affect it?
It's not related. It's have no dependency from where these documents reside in the index.
All right.
Did you try different ones like?
Yeah. So Mikhail said, just for the, because he doesn't have a mic right now, because we only have 2 mics, because, you know, I don't know. He's saying that the IDs doesn't matter, but just for the sake of a good show, to explain what we meant for people who are sitting out there, and why would the IDs matter? The reason the IDs might matter is because when it's doing the leapfrogging, right, it'll ask each of the clauses of the query, basically, what is the earliest document that matches, right? You tell me, how far ahead can I skip? And if it asks this guy, how far ahead can you skip, and that ID happens to refer to a really early document, you haven't skipped shit, and it doesn't care. And then this is just as slow as it was before. If it says, I'm actually like the third to last document added to the index, you just saved yourself 5.9 seconds. And then this guy is only consulted for the last few documents. That was the example Yannick was making about why it might be slow. Apparently, we still haven't gotten to the root of Mikhail's problem, and frankly, I'm not sure if we ever will unless he submits a bug report with a reproducible test case, which is the hallmark of every good bug report.
Another place where time could be taken up is just the fact that there's 72
right.
words up there, and just the setup per segment of doing a lookup for each term. Okay, that helps.
So he's got a single
lot.
segment
That
index.
narrows it down. Well, that should be easy to test. Then we should be able to come up with.
Yeah, we should be able to test it if we had a reproducible unit test attached to a Jira, which is my way of saying I think we are out of ideas that we can do based on this slide. Am I right? Eric, do you have any other comments? No? Yeah. Eric's like, I'm glad I did not have to try and step up on that one. All right.
All right. Any audience questions, or shall I go to a slide? Submitted one. Your other one's in here. Don't worry. He's got another one.
Do you have another comment about this one? Yeah. Okay,
Oh.
sure, yeah. Did you figure this out?
Guys, the problem a little bit deeper, and the problem is API design, and the scorer API design. How this query can leapfrog from highly selective filter or other must close. How it can jump through few documents. We are advanced, right? You ask them advanced for the doc num 100, right? And try to advance there, calculate the number of matched clauses, and got only 3 clauses matched. What should I do next? They are really stupid that it start loop by documents, which it should not really loop through, you know? Yep, it keep looping. It run next doc in a loop. Instead of this, we need to have kind of conditional advance method at Lucene Scorers API. You ask them advance jump to document number 100. It should say, oh, I can't just push me somewhere further, you know?
I sort of understand what you're saying, but to be honest, I'm not sure. Well, one, I'm having trouble remembering exactly what the API looks like, but two, I'm trying to think of how it could actually work better in the because your point is when it tries to jump, then it says, okay, well, that doc isn't mine, so now I have to tell you what's the next one. And what you're saying is really ideally you want it, for a really complicated query, you want it to say, well, I don't match that one. See what else you got. And then come back and check with me again.
I think there's a Jira open already for
to
do that, basically, so you can always talk to the filter first. And well, that's the same thing what we were saying. Depending on where the IDs are, it may or may not.
Right. No, but I mean, his point is that so for people who don't know, the internal API that we're talking about here, what it under the cover does, that leapfrogging logic that we were talking about, it's really about saying, okay, you've got two clauses. And the first clause, I asked him first, just because he was whatever. I asked him first. And he said that the first document he matched was document number 72. So now I'm going to go to the second clause, and I'm going to tell you, skip everything up to document 72, and then you tell me what's the next one you match. And if you match 72, great, I can return a score. If you don't match 72, the API currently requires you to say what the next thing you match is, right? So if you don't match 72, you have to look at 73, 74, and you have to figure out what the earliest one you match is. And what his point is here is that for this big-ass clause up here, that's a lot of work where it's incrementally checking every single one as it goes until it finds that first one it matches. And then as soon as it finds that and it hands control back, the other clauses might say, well, that's stupid because the next one I match is 127 billion. So we just spent a lot of effort going through 72, 73, 74, and he's saying if that API had a way of saying, I don't know, just fucking ask somebody else and come back to me later, if it had a way to stall like me, that it might be a better API. And that's a good point. Uwe has his hand up, but unfortunately Uwe doesn't have a mic. So if Uwe wants to participate, he needs to walk to the front of the room. Woo!
I think Yannick already told about that there's an issue open currently, but it was not committed because it was too late for 4.0. I think it is done by Simon Wilnauer at the moment. I think it's already committed in 4.1. The reason is exactly as he explained, that it might be very hard for the query to find the next matching document, so the filter should only tell the query which document matches next. So the idea here is that you have a filter strategy where you can choose if you only want to advance the filter or the query and so on, I think. But there's still the problem of the scorer when you advance forward, that it might go beyond that point.
I mean, that's no different than today, right? So, yeah. Okay.
I still don't understand why. I mean, I understand why the current skipping is suboptimal. That doesn't explain why the times would be exactly the same in this case.
He said it was a little better. He said when he added this filter, it got a little better, but minusculely better.
Okay.
Yeah. Yeah. I said it was basically the same. I summarize. I paraphrase. All right.
All right, let's go to the next one submitted by another user here. This might be kind of a quick one here.
Who asked this question? Are you here? Because to be honest, I don't fully understand the question. So if you're here and you want to come up and explain it better or make fun of me to my face, I welcome it. Okay.
I understand it, I think.
You understand it? Okay,
Yeah.
well then he's already stumped me, clearly.
There's some, I think there's just, they're assuming that, okay, to perform shard partitioning, you have to get out your documents and then re-index them. And so, what do you do about the non-stored ones? You can't.
Okay, right. Okay, so this is why I didn't understand the question. So the way I would have approached shard splitting is through a tool like the index splitter, or just naively by looking at the segment files and maybe that's if I was going to do it manually. That would be a foolish way to do it though, because we have a tool called index splitter, which is designed for that point, where you can, if I remember correctly, you give it a filter and it will decide what goes into each of the split sections. And that works at the very low level of the index, so that will actually preserve everything at that level. So that's how you could take any index, or shard in this case, and divide it up into two. The caveat to that in the context of things like Solar Cloud is that your ID space and your addressing of that shard, that's still being worked on in terms of how you can do that sort of shard management, right? I mean, that's not fully baked yet.
The whole thing isn't fully baked. We have an issue open in Solar for shard splitting, and the code, that's already done. It works. You know, you can send in a command and it splits the shard. It's just what we need to work on now is all the coordination around, you know, spinning up new cores and putting things in the replication mode. But all the shard splitting's done with the hash ranges and stuff.
Oh, the hash ranges is all done.
Yeah.
Oh, I thought that. Okay, yeah. So then the answer is easily.
All right, next submission here. This was proposed to me earlier today. Is Patrick here? Yeah, there he is. I'll let him have the mic for this one.
So on a comparison shopping site, I retrieve offers from various shops, and quite often it's as a result for a query, and quite often it's the case that the first page is all populated by offers from the same shop, which unfortunately looks not so well for the user experience. So I need to provide some diversity with respect to other constraints like the shop or the brand. That's all. I type in T-shirt and all I get is, I don't know, some T-shirt manufacturer.
Yeah. So does everybody understands the question, right? Pretty straightforward, like from a user experience kind of issue. Okay. So historically, I have two views on this. The first view I have is that this is exactly the right behavior based on the data, and that ideally you should clean your data up a little bit better to make the products more discriminate. Because nine times out of 10, when people give me an example of this, the reason they have a problem is, not because I'm saying like you're a horrible keeper of your data. I just want to get this out there to the world so people think about their problem in this way. 9 times out of 10, what happens is they aren't really doing a good job of normalizing their data or thinking about their data in a normalized way before they even load it into Solar. So they're getting data from some merchants that is a gold mine of keywords and is full of good descriptive text and has perfect product names and they're long. And then they get data from another merchant, and that merchant doesn't give a shit about anything. He's just in there to like get Google ad clicks. So his product names are all one word. He has like 2 keywords per product, if anything, you know. So the scores wind up being drastically different between those. And if you actually like treat your data equally all around, then in theory a search for T-shirts winds up being very spread evenly and fairly among people. Ideally, right? Doesn't always happen. But I just want to throw that out there for people, that thinking about the cleanliness and the equivalence of your data or the fairness of your data before you ever load it in is usually an important step. The second thing I would say is that sometimes an easy solution to this, when you actually look at your results, is you'll find that the reason you're getting kind of ugly, non-fair or non-randomized results is because the scores really are, your queries are very simple and the scores are just winding up equivalent. So the tiebreaker value in that case winds up being something like the order you inserted it in the index, and you just happen to load all of one merchant at the same time, you know, things like that. So if you look and you see that the reason your documents are all bunching up together is just because every document has the same score, then I would say you can put a secondary sort on some other field, like, for example, a random field that Solar has, which was introduced 4 or 5 years ago to solve pretty much this exact problem. That for really simple queries like one-term T-shirt, and every document matches that one-term T-shirt, or, you know, every match matches that one-term T-shirt with an identical score, and then they just come in index order. You can do a secondary sort. I mean, in your case, maybe a secondary sort on price or something like that would be good. We'll sort of the lower ones first. But you can always sort on this kind of randomized field, which actually gives you a deterministic but randomly assigned order based on the first time you do it with that field name. The third answer, though, the final answer, I guess I would say, is this is where a lot of people use result grouping. They say things like, I want to do this search, but I don't want to inundate my users with 500 T-shirts from one merchant, followed by 500 T-shirts from the second merchant. Instead, they say, I want to do grouping on merchant and show only the first 5 results from a merchant, and then at that point I cap it, and I don't show any more from that merchant. A corollary example might be category. You know, if I search for Apple, that's a bad example. E-commerce doesn't usually have this problem. But if I search for something, if I search for USB, no, damn it, that's still a bad example. If I search for HDMI, right, and I don't have a targeted category to start with, maybe I only want to show the first 5 products from the TV category, and then the next 5 products will come from the laptop category, and then the next 5 products will come from the home stereo category, things like that. And then until they've drilled down to a category, do you turn off the grouping? Those are the 3 things I would put out there to someone who is facing a situation like this, such as yourself. Yeah.
Another thing that's a bit difficult to handle. And with respect to your second suggestion, is that the different shops provide a hugely different number of offers.
Right.
There are shops which provide like 50 T-shirts, and there are others which provide 10,000 T-shirts.
Yeah.
And this further messes up
Yeah,
the ordering. So
yeah.
it's not actually possible, and a random distribution won't work either, because this will, of course, prefer the merchants who bombard us with
right. And that, I mean, that's where
number of
right.
T-shirts.
That's where grouping can come in handy there. There is a temptation. I've had people ask me about this before, and it sounds good on paper. There is a temptation to say, I know how many total products I have from each merchant, so I'm going to boost and bias documents based on the merchant and how many products they've gotten me. So the guy who sells 10,000 T-shirts, you know, his scores are penalized, but the guy who only sells 5, his scores are rewarded. But if you actually think about that in a real-world context, you're saying the guy who does really good at his job and makes a lot of variety of the product my user is looking for, I'm going to penalize him. And the dude who makes one frickin' thing that matches this query, I'm going to put him at the top. Real world situations, that's almost not, I mean, I don't know of any domain examples where that's a good idea. Like, it's like, yeah, you know, this company over here, yeah, they make like, I don't know, like toasters or something. Like, they're going to be at the top of the list because they only make 2 products. Have fun. It's just, I mean, that doesn't really work out. So I not that you asked about that. I saw you like weeping when I even brought up the suggestion, but I wanted to point it out to people when you think about that, like how can I level the playing field? You don't really want a level playing field 90% of the time. You know, 90% of the time you want the products that score higher to come first. That's why they score higher. Yeah.
So just wanted to make a comment. I've seen a lot of times people do, you know, the query and return 500 results, and then they do awful post-processing merchandising logic to winnow it down to the 10 results. And so they'll decide we have to have 3 brands in the first 10, and you know they have their own proprietary logic that does merchandising or slotting or bucketing or whatever it is they call it. So yeah. I see that often.
Yeah. And every time you do, Haas cries. Okay.
Any other panel members want to comment on this? Great question. When he asked me that earlier today, I knew that was one for you, since you fielded that one a number of times. Okay, how much more time do we have? We're done at 6:30, is that correct?
Officially we're done at 6:30, but
okay.
Anybody sitting up at the front of the room care how long we go? Other than Yannick, who's tired? All right.
All right.
Until the janitor kicks us out, I'm good.
All right, here's a good one. I think there's a pretty straightforward answer to this one, but we'll see what Haas has to say here. And this one was submitted by...
You have not stumped me because the answer is no. And I know that answer, and therefore it is easy. Yeah, unfortunately... No. I'm trying to think of if there's a good workaround to this. And I think, again, the answer is no. You could... Let me... Hold on. I'm visualizing Java docs. I think you could write a custom synonym filter that would do this. I think the API at the analyzer level will let you have access during the token stream. I believe the token stream gets annotated with the field name. If it's not, then it's because I saw a patch where someone suggested we add a field name attribute, but that's not committed. Uwe is helping me cheat. So at some point in the possible future, you could write a synonym filter that does this. It doesn't exist right now. The real question I'm trying to figure out is, in my head, could the existing Solr synonym filter be modified to take advantage of it if it did get added? And I believe the answer is yes, but it would take some work because we'd have to figure out, you don't want to be reloading that file every time a new field is encountered, especially in the case of like a dynamic field name. So it would definitely take a little work, but it should be possible, but it's dependent on that other notion that you need to annotate the token stream with the field. So short answer, no. Medium answer, no. Slightly longer answer, go for it. Longer answer, we could get it into Solar, but it would definitely take some work. There'd be some things about like caching the synonym map and deciding like how long to hang on to it, what to do if you can't find one for the specific field name. You know, like what do you want to have like a default synonym map? But I think it could work. It just wouldn't be. I like to point out to people that a lot of analysis factories in Solar are only like 10 lines long. This would not be one of them. This would definitely have to have some meaty logic to it. Gentlemen, any comments? Any comments?
So you could also just create that. You could just programmatically like create new fields in your Solar config or schema and just reload the core, right? I mean, I guess I'm kind of struggling to see why you would do this because it sort of seems like you're working against. They're no longer sort of each dynamic field definition isn't specific. It's now, you know, I would have a foo underscore text field and you create many instances of that. If you're only creating one instance of a dynamic field definition, then you might as well just hard code it or build your schema dynamically from an external repository of data.
Right. I mean, the key, which Eric just made me realize, is something's got to be creating those synonym text files. So at whatever time you build those synonym text files, you could also be building snippets for your schema.xml and then reloading the core. Because that's got to be a heavyweight. You're not like on the fly doing that, right?
In fact, I add this stuff about files just to make it more puzzling, to be honest. Okay. And,
does anybody wonder, show of hands, who here still doesn't understand why I curse this man every time his name shows up on a slide? Anybody? Anybody? No? Okay, good. Go ahead. I'm sorry, I interrupted you.
I think it's really old approach to have synonyms in files. You know, if you work for something for real life, right, your merchandiser will put these synonyms from CMS, make it dynamically, you know.
Yeah, I mean,
and the key answer is it will be different repositories, some CMS stuff, some external storage. But I need to formulate it shorter.
Yeah, no, I understand. Yeah, I mean, that's if you were doing a custom component, where you were dynamically pulling your synonyms from some data source or some CMS or something like that, then a lot of the complexity of this problem definitely. Well, I wouldn't say it gets simplified. It just gets pushed somewhere else, right? You're pushing into your sort of CMS the logic of how you maintain those synonyms, how you decide for any arbitrary field. But what you really want, and your point here is, you really want an easier way in the schema.xml to say, here's where you can go get synonyms from. I'll implement whatever API I need to implement, but then in my API, I need some way to know the field name. And right now, that's not really possible. And the way that would be possible is if we get. Do you know, this is the kind of shit you know off the top of your head. Do you know the JIRA number off the top of your head? No. Yeah, all right. There is a JIRA, though, that we have both seen, and that's how I know it exists. And it's not a figment of my imagination, because Uwe nodded and smiled when this question came up. There is a JIRA that exists where the idea is we have token attributes that we can put on token streams. And so Solar can say, okay, we're going to throw this attribute. What is the field of this token stream? And then your analyzer and your synonym factory, and we can pass it down to whatever plugin we had. Yeah, I know you need it. So I need a patch, man. That's what I'm just saying. I also need a Subaru, but I don't expect you to help me out with that. You mailed a patch? I don't even know how that works, man. Did you? Okay, it probably, I mean, I'm going to throw this out there. Between the Solar list and the Lucene dev list, I think there's roughly 200 messages a day last time I checked. Things do slip through the cracks. And I'm sorry about that. I don't know what that was, but that was creepy. So yeah, it does not surprise me that it slips through the cracks. It's definitely a very specialized thing. A lot of people are not. I mean, I get in your case, and I get especially like the CMS crew would definitely, like the people who do a lot of CMS integration would love to have more control over that. But a lot of people are using synonyms at index time in particular, so their lists are generally static anyway. And a lot of sort of what I would call medium and intro Solar users aren't facing that problem, so it's really easy to see why that issue might have slipped through the cracks. I would definitely get it into JIRA, and I would definitely look for the field name attribute issue that we're talking about and pound the shit out of that one in JIRA so people get it. Because that one, once that one's done, you could do it entirely in a very simple plugin. You know what I mean? Like even if it wasn't making it into Solar, if you implemented your plugin with all that stuff, you'd have all the data you need is the key. So, yeah. Okay.
Uwe, did you have something?
It's just a comment. So it might easily be possible, although without the field name attribute. I think you would only need a separate token filter instance for every field that is created dynamically. Maybe a possibility would be to create a custom field type for that. And that has it's not easy to configure that through the schema, but when you implement something like that, it should be possible to do that. Because the field name is not known, it might be known to the analyzer. Another thing is to simply program a standard Lucene analyzer and pass simply the analyzer class instead of the complete structure in XML.
Right. The problem though is that analyzers are on the field types. No, but they get the field name at the Lucene level, but in the schema, they're on the field type, and for a dynamic field, we don't actually construct a schema field object for every one of those. There's not a separate analyzer there's not a separate analyzer object for every schema field object in the index schema object. We could, but I'm saying that doesn't exist now. He could not go write that as a plugin today if he configured an analyzer in that way on a field type. That analyzer would not have that field name when it got to those dynamic fields. That's my point. No. Trust me. We don't create a separate schema field and hang an analyzer off of it for each one of those dynamic fields. All right. Somebody's buying somebody a beer later once we get access to a laptop. Let's. I think we're ready for the next question.
Skip one and go to one that's much more solar-centric here.
For people who can't read that, there's a lot of fields. Range queries, what the fuck? Okay,
and
so
there's 378 million documents.
Right. Okay. So for the record, I've blurred out all of this, which is fine because I don't think any of you can see it anyway. But I'm just letting you know you're not missing anything in what I'm about to say. If I come back to there, I'll tell you what jumps out at me is important. So the first thing that jumps out at me is this range query here. This range query is year star to star. It's URL encoded, but it's basically saying find me all documents that have a value in the year field. For that many documents, it's taking 13 seconds. I don't know, I guess that sounds about right. But the real key, I would say, is if this is the type of query that you're used to doing, first of all, I would definitely put it in an FQ, not a queue. Even if that's all that you need, if you're ever going to reuse it in another clause, you might as well filter on it instead of making it your main query, because you certainly don't give a shit about scores coming out of that. But the second thing I would say is if this is something you're going to do a lot of, this is where having a field called has a year, Boolean, true, false, really comes in handy, because a simple term query on a Boolean like that is going to be faster than that range query. How much faster, I can't say, but
well,
I would guess.
Here's a term query, 2 seconds.
Oh, yeah. So it'll basically be just as fast as this, if not faster, because I don't know how many individual values exist in this field. If this field is a bool, wait, I actually know this information, so I can look it up. It's an int. So I don't know how many values he's got in that int. I'm going to guess it's more than 2, which means this query is by definition going to be slower than if you made a Boolean query on this. So you could get it at least down to 2 seconds. The second thing is if you're doing these geospatial range queries, I'm not sure why you would be doing those
Well, Well, time is pretty quick on that one, so.
It is, but it smells funny to me, just in general, because...
I don't even think that's is it geospatial. I guess
well, it says it's geospatial, and it says it's referring to a coordinate field. Coordinate
we
field
don't
is
know
of type coordinate. I don't know what that is,
Right.
but I'm going to guess that it's an actual lat-long geospatial field, because then he's got this chord, which is a double. So the question I would have is, are you sure you're querying what you think you're querying there? Which is always the first thing to start with, because I don't really know what this is going to give you. I don't know why you would ever do that query. I could understand if you were using like the geofilt function, or if you were using like one of the bounding box functions or something, but just doing a straight range query on that.
That does a bounding box.
Does it?
I believe so. Yeah. It under the covers that.
Oh, these are the lower left and upper right corners of a bounding box. That's how that field type works now.
Yeah.
Oh, okay. Yeah. All right. Then maybe that's as fast as it gets. I actually don't know. But the main thing is it jumped out at me as being a code smell.
So now we're left with this one. As,
yeah.
Maybe that's just a lack of warming.
Right. I mean, I'm not really sure. Again, this goes back to not being sure. A lot of the issues of speed here come down to how many terms do you have in some of these fields. So if basis of record has a whole ass ton of terms, then yeah, it might take a little while. The things you could try here are trying the different, what do I want to call them? The different methods of faceting, or the different algorithms. So there's 3 currently. There's field cache per segment, global field cache, and term enumerator. If you have a very small set of finite number of terms, the term enumerator one is actually pretty fast. It works. I mean, that's why it's the default for Boolean. But if basis of record, if that's an int, just because you need to encode 4 values, the term version is actually going to be pretty fast in a lot of cases. But you definitely want to play with those and try those out. I think that's my best suggestion for how you might be able to speed that guy up. I go back to this geospatial one and say, I have no idea how to speed that one up. I'm going to be totally honest. Oh, yeah, sorry. You're right. That's a good. I totally forgot to even consider the fact that this is a big-ass honking index. So taking advantage of some of the solar cloud, even if you don't care about the dynamic scalability, just doing it as a distributed search to try and offload some of that work to multiple nodes, that might help speed up some things. It might also, there's an overhead though, right? I mean, there's always a cost for some of these things. So while you get some parallelization of the logic, you also add functionality, or you add execution in terms of the merging of results. So that work has to happen. It does exist, but you may benefit from being able to split that index up. So the comment there was an index this size, it might be worth thinking about splitting it up, but not just splitting it up randomly to distribute the work, also splitting it up in terms of the types of queries you're going to run and the types of logic and types of ranges or facets or whatever. Particularly in this example, if you care, if there are certain queries you run when documents have a year and certain queries you run when documents don't have a year, put all the ones with a year in one index, all the ones that don't in another. You can partition your logic and really cut down on the space of documents you search. You know, that's just sort of like an old school index partitioning trick. In Solar Cloud, I think you could do that by having 2 different collections, and most of the time you query both collections, but at query time you only query one if you know you only need one. I think those are the best suggestions I have here. I'm going to hand the mic over to Panel and Uwe.
Yes. Yeah. So one thing on the year field, if you do a lot of range queries on it, instead of like having a separate field, just saying like, you know, what has year, that should be like a tree type. So like a tree int, or if that's the original type is int currently, yeah. And then Uwe pointed out too the same thing for coordinate. The subtype, the underscore chord that's used to score the lat and the lons. Instead of double, change that to T double, which is the basically it indexes numeric values at multiple precisions to speed up range queries at the cost of some index size.
Yeah, but we don't know what he may have redefined. We don't know.
Well, that's not best practice, though.
You're assuming, yeah. You're assuming that that's what that is.
Yeah, we're assuming a lot. I mean,
And I was just going to suggest if you know you're going to be faceting on basis of record a bunch, put that in the auto warming, the on searcher or on searcher load, so that you don't a user doesn't have to incur that cost.
Yeah, I was wondering if that.
Yeah, we don't know, and it says they're sorting on a large number of fields, right? So you definitely need to warm that stuff up.
Single value, it should be pretty fast.
Right.
And this was emailed to me this afternoon, so. All right, well, I think we're going to call it the end of questions at this point, and we have to rate.
Yeah, so I'm gonna let the panel over there converse for a minute and figure out who they think stumped me the best. Normally, this is where I would make some sort of announcements that they'd asked me to make, but no one asked me to make any announcements, so I'm going to hand it to her. We have a winner, and I guess the winner is up there. Once again, Mikal has asserted his dominance at pointing out inane and annoying problems that he has found. Do we have a second and third place? Yeah, we have a second. Come on, how many times have you guys done this? Seriously, we need a second and third place here, folks. Come on. You don't have to do anything else. All you have to do is sit there, look pretty, and pick 1, 2, and 3. Come on. There's no preparation involved in this. All right, so while they're doing that, not for competition, does anybody have another question? I won't even make you hold the mic or be on camera. We can like hide your face with a black light or something. But they're talking. All right, go ahead.
Imagine an index with a huge amount of index PDF files that have maybe one single PDF has about 6 megabytes. And I want to display a result list with highlighted terms. This is a very expensive operation, I think. Is there something about what you can improve?
The first question I have, and this will just be yes, no, so you can just like nod. When you return results, are you returning pages or are you returning whole PDF documents? Like, what are your users searching for? When you say you want to return them and highlight the information, one file, one PDF file, you want that to be one document, and then you want to highlight within that document where a user matches. Yeah. Are you specifically searching only PDFs, or are you doing other things besides PDFs? Mainly PDFs. Okay. So everybody heard the question, right? Because he had the mic, so that should have been good. Yeah. The real issue is that the Lucene highlighter is not the pinnacle of Java development in Lucene. It has a lot of antiquated kind of ideas and assumptions in it about what it's highlighting and where it is. When you get into really, really big hunks of text, you have a couple problems. The first of which is you have to actually have, in most cases, all that text in Solr and Lucene, which, if nothing else, makes your stored fields really, really big. There's been talk about a lot of ways that they want to try and improve the highlighter APIs. Whether that helps you in the near future, I don't know. In the short term, what I've heard people talk about doing is, it's not something I've really thought about, so I'm trying to remember this like discussion that someone pointed out, is basically not actually leveraging highlighting in Lucene and Solr to do it, leveraging the matching, and then leveraging browser plugins to actually send back the raw PDF file along with instructions telling the PDF viewer to highlight, which is why I asked if you were specifically dealing with PDFs. I personally don't understand how that works, but apparently there are common instructions that you can send to PDF viewers to say highlight text, much like if the user did their own search, in the bottom bar. I don't know how universal that is. I don't know if you have to have a standard plugin or if it can be something you serve the user as like an applet or whatever. But that is the one thing I would throw out there, is that you just do the highlighting independently. I don't have a better answer for you than that. I'm sorry to say, but right. So Eric's point was that there is that like analysis request handler which lets you feed in text and get back highlighting. So that would be a case where you could say, I'm going to keep my index small by not actually storing all that text, but then it's a little more expensive at query time, because once you get your results, you then have to go find that PDF, pull that text out, send it back. So you're kind of damned if you do, damned if you don't in that case. All right. What is our second and third place, folks? Do we know who won? Oh, that was yours. Oh, yeah. Sorry. Okay. All right. So we got to make sure we get his email address so we can send him his prize. There are prizes, by the way. That's why anybody actually cares. And then third place was, yes. Where did there he is. You moved. You tricked me. Right. So yeah. So if your slide was up there, make sure we get your email address so we can send you your prize. And thanks everybody for coming. More sessions tomorrow. This floor. You heard about the schedule adjustment. We're going to swap 2 schedules, but you're going to come to all of them anyway, so don't worry about it. Thanks, everybody. See you tomorrow.